Welcome to the Hay Kings podcast, brought to you by Vermeer, your expert in hay and forage equipment. Today on the Hay Kings podcast, I'm joined by Gary Campbell. Gary's the crossover between the farmer and the manufacturer. Gary's operated big balers all over the world, and he's going to share some of his thoughts on the relationship between the end user and the manufacturer, and we're going to talk about some of the future of where the hay industry is going, where agriculture is going. Welcome to the podcast.
Hi, John. Thanks for having me. Yeah, looking forward to giving some insight into my experiences in the design world for farm machinery and what I learned driving tractors and what I think people can pick up going ahead. So, I'm pretty excited to be here. Oh, my accent's a pretty strange one too. It's been absolutely bastardized over the past 10 years. I did 4 years in England and I've done 10 years in New Zealand now. So this is actually a soft accent to what it was.
And then you're originally from?
Just south of Belfast, so in the north of Ireland.
Got it.
Yeah, man. Last time I went home, my parents were saying I sound like a Kiwi, and I'm like, I don't think I do. But then the Kiwis over here, they're like, you still sound super Irish. So yeah, it's all over the place.
Where did you start, and how did you get to where you are now?
Right. So I grew up on a beef and sheep farm in Ireland, fairly modest size. I think we only had sort of 40, 50 acres, which for Ireland's a pretty common size farm, and a lot of people will have a part-time job and do farming on the side. So my father was in the civil service and mum she was working in the hospital. So we were always farming in the evening or doing it the weekend and stuff. Realistically, for me and my younger brother, there's no way that's going to be a commercial size farm. Even though it's super common in Ireland, it's never going to be your full income.
Right.
I was always into farm machinery. There's pictures of me in nappies on the farm, handing dad spanners as he's fixing a tedder and stuff like that. And I always kind of knew I wanted to go into the engineering side of things. So I studied mechanical engineering when I was 16, and then this professor turned up one day from a university in England, and he's like, oh, we actually do agricultural engineering to a degree level, which was, I didn't even realize that was a thing. I sort of just thought you did mechanical and got into it. So it sort of really appealed to me, and I disappeared off to England and did 4 years of agricultural engineering, which is pretty much mechanical, but then they would do real world comparisons. So rather than just doing a stress test, we'd go out and do stress testing on an actual plough in the ground. So it was really, hands in the dirt, real world side of things. So did that for 4 years, and then obviously had to pay for my education. So in all the summer times, I was driving combines in England. I was driving MF 190 balers over in the East Coast, doing bioenergy straw baling. I did 6 months in New Zealand on a big cropping farm, because I really wanted to try and understand different systems before I went into the engineering side. I wanted to try and gather as much various knowledge as I could. So I did a stint in New Zealand and did a 6-month stint in the very north of Sweden, driving around balers up there. That was working with a guy who was the ex-factory mechanic for the Yamaha motocross team, so he was super good on the spanners. So learned a lot from him. When I finished my degree, I thought, I've seen New Zealand, I've seen a fair bit of Europe. So I disappeared off to Australia and drove combine harvesters over there for a season, which was pretty eye-opening. The place is, I guess it's pretty comparable to you guys in the States, just massive, massive swathes of land, which was just new to me, 1,000-acre fields kind of stuff. And then, so after all that traveling and driving tractors and stuff, I sort of settled in New Zealand kind of full time. And just purely by chance, I fell into a job. I was field testing for one of the big European manufacturers. So I was doing summers in Europe, and I was doing summers in New Zealand, and that was driving prototype round and square balers. So doing the actual driving off them.
You said summers in Europe and summers in New Zealand, which means you were running a baler all year, right?
Yeah, pretty much. We kicked off in Europe in June, and we were in Europe until late September. And when I say Europe, we were France, Belgium, Germany, Italy, and a little bit in Holland. And we would only go to a region for the absolute peak of the season. So we'd go in for like that 1 month window when like everything's go, go, go. Like we were only there for the peak of the season to get as many bales as we could for the machine.
Mm-hmm.
It was kind of organized around, we'd go to Italy and would bale the really tough like pasta wheat straw because it's really hard in the balers. And then we'd go to Germany because they've got real catchy weather windows. So like throughput's really important to the Italians. And then there'd be another crew in Spain doing something different because they'd be testing a different set of parameters. So yeah, we bounced around Europe quite a bit. And then sort of September time when it started to wind down, the balers got put onto a ship and they got sent down to New Zealand because I think, from what I'm aware, New Zealand's got one of the longest silage seasons in the world. Like the boys will be kicking off silage here probably September and they'll run it right through till April. And then there's a straw window in the middle, so like barley and wheat straw. In the South Island, New Zealand, there's a massive grass seed industry. So you've got all the grass seed straw as well. So between the sort of the European season and New Zealand season, you're able to put probably like 11,000 bales through a baler, which is enough for the designers to be confident that it's done a decent dash before it goes on to the markets. So
what you're talking about is prototypes. Can you take us through that prototyping process?
Yeah, so the guys I was working for, the first year they build what they call a functional model, and that's like the real rough ready. When you think of a prototype, that's what you'd imagine, like not painted, stuff welded on ad hoc. It was just proving the concept. So they did that for one season, and then they build a pre-series, which is, it's as they're envisaging it's going to be made. So it gets put down the production line, it gets made in the factory as they anticipate it's going to be made. And then it goes out to the field test engineers. We were given like a 10,000 bale target. Like we had to punch 10,000 bales through that machine before they could accept that it was doing its thing. So I drove I think it was the second of that baler ever off the line. We drove it all around Europe, all around New Zealand. Once we'd put maybe like 5,000 bales through it, we then would hand it over to the contractors. So we would select contractors in different areas and would base it on, we know they're good guys. They're not hard on their machinery. Like there's being hard on the machinery, driving it normally. They like wanting to get the work done. And then there's guys who are just rough and ready and don't give it the care and attention it needs.
The difference between somebody that bales a lot of hay and somebody that bales a lot of hay without greasing it on a regular basis.
Yeah, for sure. Because that's going to skew your results. You're like, well, that bearing failed because it's never seen a grease gun, as opposed to that bearing failed because it's massively undersized. You need to be real careful that you're looking for the right problems.
Right, and dealing with the right partners in that instance.
And then also, they would try and choose, I guess, guys with different business interests. So we worked with a guy in Italy, and he was running a bunch of Chrome HDPs, and he was shipping the stuff out to Saudi Arabia for like horse studs and stuff. So all he wanted was like as much density as he could, because the more density you get in the shipping container, better prices, obviously. But then you go and work with a guy in Germany and he just did not care about density. All he wanted was, I need the straw off this field 2 days after the combine, like at the latest, to get the seed drilling behind it. So he's running to a very different set of parameters. So you're trying to pick and choose who can give you different real world testings. And then there's another whole like range of issues where you're dropping a baler into or any machine in that regard. You're dropping a machine into a contractor or a big farmer. If it breaks down, it's going to screw over his operation. So you've got to have a driver there to back him up, or you've got to ask him, just because we've given you a prototype, you can't take on double the work. Like, we're not here to add to your business. You've got to run it like your own baler, so if it falls over, you haven't got crop on the ground. Because when it breaks down too, it's not just like a normal breakdown where you go to the dealership, buy a part.
The part might not be in production yet.
Yeah, the part's not in production, or it's also, if it does break, we need to know why it broke. So like, we were going through an issue where the pickup was plugging ever so often in certain crop conditions. And like, that turns into a 5,000 word report, 20 to 100 pictures, all labeled. This is where the grass is jammed. It's wrapping around here. This is what we think's happening. This is the moisture content. And that will go back to the head office and the designers. They'll pull it apart and try and work out what's going on. So you might not have a fix for a day or two, but then when you do have a fix, it's just all hands on deck. We had guys couriering parts across the continent overnight to get it to us in Germany to fit it the next day. So yeah, it's a massive juggling act, but it's always good times. Pretty exciting.
I'm Tom Swin, and I switched to the Vermeer TM1410 trailed mower. The biggest impact is capacity. We're just getting more hay mowed. It's hard not to be impressed by 20-foot mowing and how much you can get mowed in a couple of hours. We went from 5 acres an hour to 12, 14 acres an hour real easily with this. And that's why I switched to the Vermeer TM1410 trailed mower.
Hear the full story at makinghay.com/haykings.
You've run balers all over the world. What's the toughest conditions you've been in?
For crop straw, so like wheat straw, I would say Italy, because we were in the north of Italy on super steep ground. Like we had like 300 horsepower on it. Actually, about 350 in the front of a 4x3 baler, and it could barely drag it up the hills, and it was very tough straw. So that'd be the hardest in that. Silage, I'd probably say northern Sweden would be the hardest terrain I encountered, because of the permafrost. Every year, the frost will actually push stones up out of the ground. So we would cultivate the fields I think it was a 5-year rotation to change the grass, because the grass eventually just dies from the permafrost. But we'd stone rake the field, and every year the permafrost would push up more stones. So the pickups were just getting hammered with stones. So that was pretty tough on them. But I think probably the worst stuff I've had to deal with is probably South Island, New Zealand dairy ground. So I don't know what it's like in the States, but in Ireland, you tend to have your silage fields, which they're only used for silage. Like you don't put the cattle into it. The grass is fertilized and sprayed, and the grass is rolled. That is your premium crop. Like that is what's going to get you through winter. Whereas in New Zealand, because they don't overwinter the cattle, like they're outdoors 24/7. They tend to take silage off the fields that have got, like they've got ahead of the herd, so that they haven't got the rotation of cattle through to, I should say cows really. They haven't got the cows to that grass in time. So it's kind of got ahead of them. So okay, we'll close that field off and that'll become silage. But of course that field has had a herd of dairy cows in it, every 10 days for the whole year. So it's pockmarked up, it's rough. It hasn't been prepared for silage. So that was just hammering like the pickups and the wheedles and that kind of stuff. There's often pivot irrigators down here, so they leave big trenches. So you're not paying attention. You hit a pivot trench at 15k, and all of a sudden your pickups up to the bump stops getting smashed up.
That's like 8.5 miles an hour for anybody that's doing the conversion in their head.
True. Yeah. So because it was never prepared for silage, it's got away. It's quite short. It's quite wet, quite dank, and that was always hard to bale. So yeah, there's definitely a few different challenging ones. But yeah, I'd reckon short, wet New Zealand grass is one of the hardest stuff I've had to bale. Yeah, just because the ground it's on, and because it's just hard stuff to bale. Like it's just wet, it's short. The baler doesn't want to pick it up, which is why it was a great test bed too for us. But it was one of the more difficult ones.
All right. What's the most fun you've had out in a hayfield running equipment?
Honestly, it's the field testing. Like anyone who knows me or knew me when I was younger, like driving for contractors and farmers, like I'll put my hand up and say I was a bit of a rough driver. Like I was always a bit ram-stam, a bit heavy on the throttle, like wanting to get stuff done. And then I went to the field testing gig, and I've never before been told by a boss or manager, you need to drive harder, you need to drive faster. Like it was just like red rag to a bull. Like you can drive that machine as hard as you want, and it doesn't matter if you break it. It's actually
that's the goal.
Encouraged if you break it.
Right.
Like that is fun. Just being rough to a piece of machinery on purpose is quite enjoyable.
I don't know that I've ever done that. I've been rough on a piece of equipment.
You wouldn't do it on purpose, it's unheard of.
Right.
But like that, it resulted in a few pretty decent stakes, quite a few decent breakdowns. Like I remember I was down in New Zealand one time, and the baler I was working on in Europe, we hadn't plugged it in New Zealand. Like, this thing was amazing. Like, it would suck up whatever you pushed into it. And then one day I jammed the chute, like the pre-chamber up and below the plunger. Normally this baler would clear itself. Like, it would just cycle the pre-chamber and eventually clear the plug, and you'd crack on. But like, this time it just wasn't working. So I rung up the designer in Germany and went, look, mate, this has never happened before. Like, what do you want me to do? And he's like, okay, just open all the panels, get your video camera out, start a video, and just run it at absolute full noise until it clears itself. So, okay, like, open all the panels up, got the camera out. And this baler was at like full noise for 5 minutes straight, just like banging and clanking and trying to clear the blockage, and it wouldn't. So I rung him back with, look, this is not clearing. Like, what are we going to do? He's like, oh, okay, well, I guess you better pull it back to the workshop and we'll see what's actually wrong with it. So we got it back to the workshop, pulled all the pre-chamber out, and somehow the rake driver had picked up part of an old bale from last year that was like hidden I don't even know how it happened, but there was a bit of an old bale lying there. So like, we fed a fully formed flake into the pre-chamber and just plugged it. But the baler, because the designer wanted me to run it at full gas until it cleared, it actually knocked out every bit of timing on that baler.
Oh,
the main gearbox arms were like shrink fitted onto the shafts.
Yeah.
And like, that was how they were timed. And it owned it all completely mounted the gearbox, and that resulted in like a whole gearbox redesign. So like, that sort of stuff was amazing. Or like in Germany one day, you've got the big flywheel on the front of the square baler that holds the main PTO clutch pack. And this was quite an early machine, so it didn't have any covers on it. We're baling away, and I still remember it like in slow motion. It just, all the bolts that held the clutch pack onto the flywheel just snapped, and just witnessing a clutch pack, a PTO shaft, and an angled gearbox just get sucked into a baler. You're like, oh, I'll just stop this and make a phone call. Like, stuff like that it was just funny, you know? Like, all you could do is go, oh, well, it's going to be a late night tonight, I guess. Yeah, stuff like that. Like, I definitely miss that kind of stuff, like just getting out and driving machines hard.
I had a drawbar come loose one time. Somebody didn't put the retainer clip in the pin that holds the drawbar in, and
yeah, it's a classic, that one.
You might be talking to the idiot that did it. I made it about halfway around the field, and the swather that I was pulling, the drawbar telescoped out, PTO shaft telescoped out, and that PTO shaft spinning at 540 RPM. I watched it hit the one tire, and nice and slow, just like you're talking about, slow motion, spin around, hit the other tire. And I don't know, this was 5 or 10 minutes worth of time in my mind from the time it hit the one tire to the next. And then it went back and hit the other tire again. And about then I came back to reality and shut the PTO off, and, spent the next half an hour putting everything back together, and then another hour going for a hydraulic hose because I broke the hose on the lift cylinders. But no, I understand those are kind of fun learning experiences.
Yeah, and like, not so much on the balers, but like in later years when I was designing New Zealand farm equipment. So quite often I would, because I was in a small company, so I would often help the boys on the shop floor build the prototype. I would talk to the local dealers and find a suitable candidate for field testing. Quite often I'd actually drive my own prototypes. So when you get to see those like explosions happen on a machine that you've actually designed yourself, like, it's incredibly rewarding, because you're out there using it and it breaks. You go, I didn't think about that. Like, I can go and fix that. Like, that's like a whole nother level of job satisfaction.
This is a very different conversation about equipment design than I ever have with a farmer, right?
Yeah, they definitely come at it from a certain point of view, and the view is generally, why doesn't it work for me? Is the view I've usually come across. But
right, or I'm sure your favorite, the engineers are idiots that have never seen a tractor.
Oh, for sure. And like, even when I was field test engineering, and because we were having to fix, not only was I like doing the driving and doing the field reports and drawing, like seeing what was happening, I was also essentially a mechanic putting spare parts on. And you'd be like, why is this bolt here? Like, this is so difficult. Like, why is it here? This some idiot has done this and not thought it through. So like, I've been guilty of cursing those guys too. And it's not until you get to the other side of the table, you go, the bolt's there because if it's not there, the guy on the assembly line can't access it because when they build that machine, it's built towards to how it gets disassembled. So yeah, it makes sense. I can see why it's there now, but it still sucks.
It does make sense from one point of view, just not from the end user. Okay, all right.
Yeah.
What other thoughts do you have?
I was thinking about, some people don't understand that there's like price point that the market has already set, and you can never really go too far beyond it. A square baler costs, let's just say $100,000, and a square baler has always cost that. If you did something crazy and new that's going to have 200% capacity and you brought it on the market for 250,000, no one's going to even look at it because the market expects you to make a baler for 100,000, and you can never get away from that. Like, it's really set that the market expects a certain price and that's what they're going to pay. I'd love to be able to remember the manufacturer, but I've searched and I can't find it. But there's an Asian, I think it's rice harvester. They developed harvesters over, I think it was in Southeast Asia somewhere. The first rice harvesters they made were built from old excavator parts. So they'd have like a crawler track off an excavator. The cab was off an old HGV truck. It was all like hobbled together. And they built them really, really cheaply. And farmers went, this is awesome. We've got a machine that can harvest our rice. We're getting more gains. We're getting more productivity. These are brilliant. And they made them for like 10, 15 years. And then the manufacturer finally made their own machine with like all of their own componentry, and it was bespoke for that job. And the market was like, we're not paying that. That's 10 times the price of what these old things were. So there's actually a manufacturer over there now only make their machines with componentry from our industry. So they've still got the crawler tracks off a digger. They've still got the cab off a truck because that's how they make them cheap. So even though they could do something better, it could make it more productive, faster, whatever, the market's like, no, we're going to pay this price, and that's just the way it is. And I think that's just a brilliant case study in that part of the market, you know?
The market has expectations of the product to be built. Thank you so much for joining me today. This has been a very enjoyable conversation.
No, thanks for having me, John. I hope people find it interesting and get some takeaways from it, and it's been cool.